So the question is saying we want to find the equation of the normal to the curve y equals e to the negative x at the point where x equals 3 in exact form. So note that the normal is going to be the line that is at 90 degrees or perpendicular to the tangent at that point x equals 3. So let's start off by finding the gradient of our tangent. So to do that, we're going to want to find dy dx of our y equals e to the negative x. So we want to find the derivative of the power first. So the derivative of negative x is negative 1. So this is going to be a negative. And then the derivative of e to the negative x is just e to the negative x. So there's our derivative. And we want to know where x equals 3. So where x equals 3, what we're going to get is that dy dx is equal to negative e to the negative 3. And what that is our tangent gradient. So m1 is equal to negative e to the negative 3. So that's the gradient for our tangent, but we want the normal. So that's perpendicular. Remembering our rule, m1 times m2 equals negative 1 will give us a perpendicular gradient. So we know that m1, we've just worked that one out, is negative e to the negative 3 multiplied by m2 is going to equal negative 1. So they're both negatives, so we can just cancel those out. So e to the negative 3 times m2 equals plus 1. So what that is saying is 1 over e cubed times m2 equals 1. So I need m2 and e3 to cancel each other out. So the way that that's going to happen is if m2 equals e to the power of 3. I could multiply both sides by e to the power of 3, and then we're going to get e to the power of 3 over e to the power of 3 cancel each other out. It's just 1, so we get 1 lot of m2 equals 1 times e to the power of 3, which is just e to the 3. So there's our gradient for our normal. So now we need to find the equation. So this is y minus y1 is equal to m lots of x minus x1. So if I substitute in my known things that I've got m2, which is our gradient. I know x1, which is 3. The other thing is y1. Well, how do I find out y1? I need to substitute x is 3 into our equation. So if I do that, we get that y1 is going to be e to the negative 3. So now I can substitute that in. We get y minus e to the negative 3 equals my gradient e cubed outside of x minus x1, which is 3. So what I can do is multiply through everything inside my bracket, and we're going to get y minus e to the negative 3 equals e3x minus 3e3, just by expanding my brackets. Let's bring everything over to one side. Therefore, y minus e to the negative 3 minus e cubed x plus 3e cubed equals 0. So now what I want to do here might not necessarily be clear. What I want to do is divide by e to the 3. So then what we get is y on e3 minus e to the negative 3 on e3 minus e3x on e3 plus 3e3 on e3 equals 0. So what happens is that e3 and that e3 cancel out, that e3 and that e3 cancel out. So what I now have is y e to the negative 3 minus e to the negative 6 then we're going to have minus x plus 3 equals 0.